Okay, so if I pick up where I left off, I am going to head back home because I still need to do my convergent boundaries. And my directions tell me to click my right facing arrow. So if I do that, it has plate 1 going to the right, plate 2 going to the left, which means they would collide. So I'm going to click see plates over time. And if you look, I have two pieces of continental lithosphere colliding, and that matches what I have on my data table. So I can go to continent colliding plates. And I am going to choose 20 million years again. And I am going to click run, and I'm going to watch to see what happens. So when two plates collide, I see my earthquakes, and I start to see what? I hope that you're saying mountains. Okay, so if I look, as they collided, some pushed up, the continental crust got very thick, the convection current continued to happen. So in my notes, I would say that there were many earthquakes, right? I would also say that the plates collide and push up to form large mountains. Okay. You could also say that the continental crust became thicker. Let me fix that. Okay. All right. And then let's say that mantle convection continues. Did anything happen with the water? I would say no. There was no water to be had. It was two pieces of land. This is what we saw when India collided with Eurasia, and the two continents collided and they pushed up the Himalayan mountains. Okay. If you look, now I got a new box. It says, what if two oceanic plates collide? That's different. So I'm going to click on that. And now my land is way over here. I have the darker oceanic crust and the two plates. So here's the boundary between them. And the two plates are going to collide. So I'm going to choose 20 million years again. And I am going to run that simulation and watch for differences than what I saw with the land. Okay, that was a lot, wasn't it? Um, I'm hoping that you notice this part right here where one piece of oceanic crust dives underneath the other, and we call that the subduction zone. So that's important. And we have our volcanoes that make islands because they're in the middle of the ocean. Notice this crumpling right here. So where this plate is going underneath and melting back into the mantle, and then magma is being pushed up because of the extra pressure, the other plate is kind of crumbling a little bit and being destroyed. So when I write that in my chart, I am going to write that we had many earthquakes. I am going to say that there was a subduction zone. I am going to say that let's go back and say there was a subduction zone where one plate is melting and going under while the other one is crumpling. Right? Okay, we would also say that magma rises to the surface, creating underwater volcanoes, followed by, well, let's say, and eventually, volcanic mountains. Okay, spelled that wrong. All right, so that's what we saw happen. How about the water? So is there any change to the water? You should be saying no because it's in the middle of the ocean. So there is no change because the entire plate boundary is in the water. Okay. So I hope that was helpful. Like I said, that is a trickier assignment, and I wanted to make sure that you were all able to do it with very little stress. If you want to go back and play with that simulator, you are more than welcome to do that and see if you look for those results that I pointed out for you. But I wanted to just make sure that you were able to get to those right answers together with all of us. So I hope you enjoyed the help, and we will be back together in our next class for lesson 6. Okay, guys, thanks a lot for paying attention, and I will see you next time.